Hi, I'm Roberto and I'm going to teach you physics. Today my girlfriend came to visit me and she's waiting until I record something. What could I explain to you? If I were in the faculty, I would have experiments, but I don't. Going to tell you why if you fry fish or use garlic in your kitchen, the smell ends up in your room. Okay? Smell in your room. Which is a very common problem that we find when we cook. So this has been discovered. The reason, in other words, it has been applied to other things in architecture in a lot of cultures, but not for the frying. Okay. But even the Romans and later the Arabs discovered that when you make a house, okay, if you live inside, you leave a patio, you leave an empty space inside, seen from above. This is the house, and there's here the rooms, blah 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 blah, the door, and then open air part in your house. It's good because you have air currents, so you're cooler inside. These air currents are responsible for, this is the patio, okay? And even in my house, I have this patio, okay? Inside, it's the building, and then there's an empty space, okay? An empty space. This is dark, otherwise I will show you. These air currents are responsible for both things. And it took some centuries to get the right equation to describe this phenomenon. What's the equation for ideal gases? The equation for ideal gases. Equation for ideal gases. The pressure in a gas, the pressure is, okay, so you consider a room filled with air, a space filled with air. The pressure is the force divided by surface applied to the particles, the particles inside. The pressure times the volume, this is pressure. And this is the value of the gas. Pressure and value are related. So if you compress the gas, you reduce the volume, the pressure increases. For instance, in these bottles. There's the gas which has been compressed in a small volume. So small volume means high pressure. There are higher pressure, it says in the so it can explode if you live you throw it to the fire, you live in a very hot place. Okay. And then there is a constant was discovered. Very difficult to discover this constant, the ideal gas constant. Of course, something. The N, which is the number of moles. A constant, and the temperature. This is the constant of ideal gases. Ideal gas constant. And this T is temperature. So this equation relates all the parameters that are able to describe a gas. The pressure, okay, the pressure is the force divided by surface, the force that the gas exerts divided by the surface on which it applies. the volume, which is, yeah, the dimensions in which the gas is. This cost, the number of moles is quite long the explanation, but the idea is related to the quantity of gas. The quantity. R is a parameter that relates small scale and big scale of, macroscopic parameters of the gas with microscopic like pressure and volume. And temperature, you know what is temperature, but temperature is related to the speed, the average speed of the molecules. Okay, so no more details. One day I explained to you about the number of mole, what is a mole, and Avogadro number and stuff. Because I don't know exactly the details. I know that Avogadro number is a certain number, very big, and then a mole is the amount of substance that contains the Avogadro. But I don't know exactly where Avogadro number comes from, and they never bothered to explain to me, and I never bothered to look for it. So for me, the Avogadro number is something as common as, I don't know, Christmas Eve. So why Christmas Eve? You never consider much about it. Okay, so I was taking the time. So what happened? Let's go back to our problems, so we will understand. What happens when you cook in your kitchen? You cook with fire, so you have higher temperature. Okay. And then in your room, the temperature is lower. The equation of the ideal gases tends to balance this stuff. So, because PV equal nRT, so it must be constant both in your room and both in your kitchen. So if one factor changes, the other has to change. The volume is constant because it's the volume of your house, or because the windows are closed. So the volume of air is almost constant. So when in one room you reduce the temperature, or the temperature is smaller, pressure, the other way around. Let me think. Temperature increases. Oh yeah, that's it. Temperature increases here. Decreasing. Yeah, so consider like that. You have an extra amount of energy, yeah, so temperature increases. So yeah, that's it. So pressure increases because you have the extra energy of the fire. Okay, so pressure increases, and we know that, fluids move toward the decreasing pressure. A little experiment. But we know that fluids, that's the key of it, we can consider so far as an axiom. Fluids move towards decreasing pressures. So, what do we have here? That in your room the temperature is lower, so the pressure is lower. What modifies the equation of ideal gases is the heat. You add